proud to introduce the H2Go bicycle-powered water filtration system. My teammates are Betzabi Gonzalez, Dan Hernandez, Sandra Alzate, Justin Cromartie, and our advisors, Dr. Andre Tremont. Clean water is essential to human life, yet 768 million people don't have access to this. That equates to roughly 1 in 8. And delving further into statistics, you can also see that every 21 seconds a child dies from water-related illness. Even in the more fortunate areas where they have some sort of water containment, the jerry can weigh 40 pounds when full. Next slide. Sometimes people have to travel up to 4 miles just to fill up this can, which makes it very unreasonable. Our plan is to create an attachment that can allow purification of this water from these sources, as well as decrease travel time to and from. We believe that it will provide a lengthy duration for improved quality of life, as well as helping them with home. Our potential areas of use will be sub-Saharan Africa, focusing mostly on Congo and Kenya, as well as South America, Caribbean area, and parts of Southern Asia.
All right, so the problems to consider for our project would be the availability of the materials in each country. Now, the aim for our total cost is of about under $500. Now, because of the limited resources that some of these underdeveloped countries have, the materials that we're gonna select must be very durable, and also the maintenance must be very limited. Also, our device must be applicable to different terrains and very easy to use to avoid any user errors. Now, we have been looking at two current examples, the CycleClean and the Aqueduct. Now, the CycleClean is manufactured by the Japanese company Nippon Basic, and the Aqueduct was made for the innovative dye competition. Now, both of these bicycles are able to filter water while you pedal, but only the Aqueduct is, you can filter water as you go, as well as it has storage capability. Now, the CycleClean has a market value of $6,600, and the Aqueduct, because of its design and the materials that it uses, it is way too expensive to mass produce. So for these reasons, we are not going to be working with them, but only using them as references. Now, the difference between our design and these models is basically that we are going to have the sidecar, which will have the filtration system, and it will be retrofitted to any pre-existing bicycles. Now, the design considerations that we're going to keep in mind are going to be that we're going to use the user's kinetic energy to power our pump. It will be a lightweight design so that we can counteract any momentum problems, and possibly implement baffles in the water tank. And also, the ideal water capacity would be of 20 liters.
We'll be using a peristaltic pump to pump our water through our system. We will be making our own peristaltic pump because all the pumps that we have found on the market are either too expensive or they don't fit our design criteria. Initially, we'll be using a 3-roller pump as opposed to a 2-roller pump to steady the output flow. And the advantages of a peristaltic pump is that it's easy to clean, easy to maintain, and very long lasting. We'll be using 2 filters. As per right now, we'll be using a sediment filter and a 3-way inline filter. The Sawyer 3-way inline filter is made up of hollow membrane U-tubes, which its pores are no bigger than 0.1 microns. The manufacturer ensures that 99.9% of bacteria, protozoa, and cysts are removed that cause illnesses such as E. coli and salmonella. They also have a 1 million gallon lifetime guarantee. And the sediment filter will precede the Sawyer filter to ensure its longevity. One of our main points in our design is to facilitate the transportation of water from its source to the people. So we'll be using a sidecar, which is a sidecar, instead of other attachments, because we feel that we can optimize it to carry the most load. We got our inspiration from the Extracycle sidecar. We wanted to fold over the rear bicycle wheel when it's not in use, and our sidecar will be detachable and easily retrofittable to most standard bicycles.
So here we have the sidecar attachment that we propose to fulfill in the near future. We're still under further development, but we have a core idea of how we want this attachment to be set up as. As you can see, the sidecar attachment consists of a peristaltic pump where the pedaling motion will go ahead and activate the water flow through the set of hoses enter the filtration system, and produce fresh drinkable water. In order to fulfill all these requirements, we need to set up many tests on the pump, the filtration system, and the sidecar. For the pump, it will undergo many different water conditions where there will be no sludge, and other sediment filters until there's a point of failure. For the filtration system, we're going to have a water purity test before and after running through the water filtration system. Also with the red dye testing to ensure that the effectiveness of the filter is fulfilled. And as for the sidecar, we'll perform a SolidWorks load simulation for load, fatigue, and testing, and also an outdoor testing to go ahead and test for any maneuverability, any balance, and load capacity of the jerry cans. So once we have our sidecar in motion, we just want to collaborate with these organizations, the Water Project, Charity Water, or Water.org. They have a certain mission, and it's to spread the awareness of water scarcity. So why not collaborate with these companies and fulfill the same global impact that they want to?
Questions? Comments? That's it? It's only you.
All right, so you're specifically using this, or your specific region is like Sub-Saharan Africa and South America, right? So what are the main causes of problems?
Organic,
in this
yes.
area?
Or
Is
most-
it bacteria mostly?
Yes,
Yeah,
yes,
mostly.
yes.
Okay, so in those three. So it might be nice just to put that there, that, quite a bit of the issues with clean water that people have is solely due to bacteria, and if we can just create a filter and filter the water right through there. So, just so that we know one-to-one, okay, this is solving this exact problem. So, go back a couple. So I know on the evaluation form, things like that, and there's things like timeline and all of that. So just, one of the big things we're hoping from you guys is to have just a plan for the future on what tasks need to be completed. You guys have three pretty straightforward tasks of, one, create the pump, two, filter some water, and then three, make sure that all of this works together. So you should define those three tasks and kind of how each one of those is going to be completed, right? So how exactly are you going to actually make the device? So you're going to make it yourself?
Yeah. It's basically rollers, and you attach it to a centerpiece, and then you use elastomeric tubing
Gotcha.
on the outside with a housing in it.
So it might be worth just, again, it's not the end of the world, but just explain those individual components and, ways that you could, cost analysis and stuff like that, so that we feel pretty comfortable that you guys can put it. It's not
Yeah.
too hard of a design, but in terms of cost, I think it would be interesting to go through it all, but the cost is all that high. But if we don't see that right there saying that you guys can do it, it makes it tough to assess that work. Other than that, just a couple things like the water project, that work is kind of hard to see and stuff like that. But so just take a quick look through it. But other than that, yes, for the most part.
Thank you very much.
And just to add to what Ben said, the evaluation form, have you spent any time looking at all of the line items that you evaluated on?
We have it.
You should.
We have
Yeah, just take a quick look, definitely. Yeah, because there's a couple things that it is what it is, of course, but if you just have that one slide there, it makes it a lot easier to go, oh, 5, rather than, oh, 1, it's not there. So, yeah.
Any other questions? Okay, thank you.
How do they go in